Hey good people, Arthur Morris here, and we're back for another video here. So this one we have the special products of radical expressions, conjugates, and squaring. So conjugates, very quickly, is when you're multiplying the sum and the difference of the same terms. So like this second group here where I have the square root of x plus 3 times the square root of 3 times the square root of x minus 3 times the square root of 3. Those are called conjugates because it's the same terms but a plus in one parentheses and a minus in the other. So I'm going to go back and use the rules that we learned for the special multiplication of binomials. And the first one here, we're going to use the rule of a minus b squared. So that will give us the first term squared minus 2 times each one of the numbers plus the last number squared. So the first number squared minus 2 times the numbers, each one of the numbers, 2 times those numbers plus the last number squared. And then for the second problem, we're going to use the difference of squares rule. So the conjugate rule here would make that the first number squared minus the second number squared. Alrighty, so those are the rules we're going to use. So the first rule I'm going to use is this one here. So in this case, the square root of x is in the place of a and the square root of 3 is in the place of b. So the first number squared minus 2 times the numbers plus the second number squared. So instead of using FOIL or the long FOIL or distributive property, I'm going to use that rule there. All right, so remember the square root squared just gives you what's underneath the radical. So the square root and the exponent square, if the root and the exponent are the same, they cancel each other out. So that just gives me x there. Then here, I can put the x and the 3 underneath the radical since they were both underneath the square root. And then at the end, I have the square root of 3 squared again, same thing. The radical and the root cancel each other out and just leaves me with 3. There's nothing that I can combine or simplify here, so that would be my answer for the first one. Now I'll do the second problem in blue. Again, I'm going to use the a plus b times a minus b rule on this second problem, where it says the result is the first number squared minus the second number squared. So we have the square root of x plus 3 times the square root of 3 times the square root of x minus 3 times the square root of 3. All right, so the first number squared, or the square root of x squared, minus, using this rule here, a squared minus b squared, minus the second number squared. Now, my suggestion to help you out is that you break up that second part here and rewrite it as 3 squared times the square root of 3 squared. Just my tip to you. I think that might be helpful for you, maybe not, but either way, you need to see that you must square the 3 and you must square the square root of 3. So the square root of x squared, again the root and the exponent cancels out. 3 squared is 9. The square root of 3 squared, the root and the exponent cancels out, so that just leaves me with 3. So 3 squared is 9. The square root of 3 squared, the root and the exponent cancels out and just leaves me with that 3. So x minus 27. All right, so let's look at another one. So here we have the square root of x minus 2 squared. So we have that same rules, but let's write down all three of our special rules so you'll have them. So special rule that's not being used in this problem: a plus b squared, first number squared, plus 2 times the numbers plus the second number squared. The rule that we will use in the first problem is a minus b squared. So the first number squared minus 2 times the numbers plus the second number squared. And then the conjugate rule, a plus b times a minus b first number squared minus the second number squared. So for this one, we will use rule number 2 and rule number 3, just like we did with the last problem. Okay, so let's start off with the square root of x minus 2 squared, minus the square root of 2 all squared. So again, it's the first number squared minus 2 times the numbers plus the last number squared. So that's using rule 2, where in this case the square root of x is in the place of a and the square root of 2 is in the place of b. So the square root squared, they cancel each other out, and this leaves me with x. And then 2, both of these are underneath the radical, the x and the 2 there, so I will write them underneath the radical together, one single radical together. So square root. And then the square root of 2 squared, again, they cancel each other out and just leaves me with 2. Okay, the conjugate rule here. That's the a plus b times a minus b, and that equals results in the first number squared minus the second number squared. So you don't have to use the full distributive property or FOIL if you learn these rules for these problems. Now in some we may not be able to use those rules, and we'll have to use a distributive property or FOIL to multiply them out. So the first number squared minus the second number squared. Again, just a suggestion, and you don't have to, you need to make sure that you square each one of those, the 2 and the square root of x. So mentally I'm thinking 2 squared times the square root of x squared minus the square root of 2 squared. So I have to square each one of those, the 2 and the square root of x. All right, so 2 squared is 4. The square root of x squared, the root and the radical cancels out, minus the square root of 2 squared, the root and the radical cancels out. So we end up with 4x minus 2. Alrighty, good people. I hope you found that to be helpful. Thank you.